seconds. We'll allow, there's quite a number of people registered, and we want to make sure any latecomers have a few seconds to get in here before we get started with this great webinar today. So give us about 30 seconds. Okay, we're going to get started. Good morning, good afternoon, good evening, depending on where you are. My name is Alan Schimmel, and I am the Senior Editor-in-Chief of DevOps.com. Thank you for joining us for another in our series of webinars here at DevOps.com. We're very happy to have CloudBees, the Enterprise Jenkins company, sponsor this webinar, and we think it's going to be a great one. Today's webinar is you can't do DevOps, but you can do continuous delivery. Enable continuous delivery on the path to DevOps. Today's presenter for our webinar is Dan Youngst, Head of Product Marketing for CloudBees, the Enterprise Jenkins company. Dan, thanks and welcome to DevOps.com.
Thank you very much, Alan. It's a real pleasure to be here, and thanks to all the attendees out there. Look forward to speaking to you, and hopefully you get some valuable takeaways from this conversation today. It's an interesting topic, and we're excited to talk about it. I created the title to be a little bit provocative because DevOps is certainly, an exciting and interesting space and buzzword these days, right? But there's some fundamental tenets around DevOps that I think we all need to understand. So we'll talk about the relationship of DevOps and something called continuous delivery. Prior to doing that, I wanted to introduce some of the drivers, the things that are really driving people to look at DevOps and to look at continuous delivery, in the industry, really what's happening out there. We'll talk about really defining what continuous delivery is, and then we'll talk about some strategies for implementing continuous delivery in your world. And then we'll round out with talking about how CloudBees Jenkins Enterprise, the CloudBees product portfolio, really can help you fulfill your continuous delivery vision. So let's start by talking about the state of the world today, right? There's some what they call memes out there, some buzzwords and phrases that people say that are becoming quite popular, and really try to describe the state of the industry. The first one was I think first said by Mark Andreessen. Software is eating the world. What did he mean by that? Well, he meant that everything that we do and everything that we touch today is driven by software, and software is becoming an integral part of our businesses and our personal lives and the products that we use and everything. So the ability to create and deliver software is becoming super important. Other folks have said, and I found a number of quotes of this on the internet, every business is now a software business, right? Every business has to become a software business because software is how businesses operate today. You need software to run your business in almost any fashion. And fundamentally, it's really becoming an application economy, right? We use applications to do everything, whether it's on our mobile phones with mobile banking, depositing our checks remotely with our mobile phones, running applications on our computers, using applications in our cars. Applications are everywhere. And there's these three trends that are driving this that a lot of people talk about, right? Mobile computing, everybody has a smartphone. Cloud computing, which is providing the back end for a lot of these applications so they can run in a very scalable and elastic fashion. And then the latest is Internet of Things, right? How every device is going to be smart, and every device will provide you data and help you better, run your life with intelligence. So these, technology trends are really one of the forcing functions. The need for businesses to be, stay competitive and to provide services for their customers, and in order to, operate efficiently is another certainly a key forcing function. I thought I'd just show up a couple of quick examples of how software is impacting our daily lives, maybe things that you haven't seen before. So this screenshot is of a cockpit of an airliner, that may seat 200 or 300 people, right? Well, if you notice this little sign in it, it says "Do not remove the power up to the aircraft because software installation is in process," right? So that's pretty important software. This is mission critical software that's going to be flying this plane, so you don't want to interrupt it. And so you need that software to be delivered quickly, and you need it to be delivered accurately, right? So you can't have any bugs in the software, certainly, and you can't have any glitches when you're installing the software. This scenario actually happened to me a few weeks ago on a flight from Charlotte, North Carolina to London Heathrow. We were getting ready to take off, and they had to reinstall the software on the navigation computer, and it took a couple of hours to do it. So again, we wanted to make sure they did it right, so we were happy to sit there and wait. But any time that could have been sped up would have been really would have been helpful to all of us who were on the back of the plane. So again, software here is mission critical. Software needs to be delivered quickly, and software needs to be delivered accurately, and it needs to run well. So if you go from this airplane to this screenshot here, we're now looking at the latest, probably one of the newest airplanes to be delivered, which is the Airbus A380. You will notice a couple of key differences here. The first is there's no control stick in the middle of the for the pilot and co-pilots to use. There's side stick controllers, and what these are what they call fly-by-wire. So fly-by-wire means that there's software. The controller is driving software, which then controls all the ailerons and elevators and vertical stabilizers. So software is the lifeblood of this airplane now, right? You can also tell that because there are full keyboards accessible to the pilot and co-pilot in this airplane. They have these keyboards because they're accessing what they call the electronic flight bag. And that's all the operations manuals and all the charts and maps are digital now. And so they need to pull up a different airport map or a different chart or fill in a log. They're doing that via these keyboards. So again, software is immensely critical to this technology. It's literally mission critical because our lives are hanging, are being supported by this airplane that's carrying 500, 600 people across the ocean. So again, mission critical. You need timely updates. You need to be able to push software to this airplane and update it, very quickly. So if we go from this dashboard to this dashboard, this is from the Tesla Model S automobile. So Tesla is one of the newest automobile makers, and they are building cars with very big dashboards with screens, and these cars are literally driven by software, right? Tesla actually pushes software updates over the air to their automobiles, and they can do that. They can update the dashboards, they can update the functionality of the car by doing so. In fact, they recently pushed out their new autopilot capability, kind of a self-driving capability via a software update. So once again, delivering better software faster becomes mission critical to this company, right? They are on the leading edge. What's interesting is if you'll notice the dashboard on this automobile, this Tesla, looks a lot like the dashboard on the A380. Big screens showing a lot of detail, giving the driver a lot of feedback about what's going on, what's the state of the vehicle itself. So just some interesting examples of how software is impacting the things that take us from one place to the other today. So it's more than just mobile phones now. It's more than just your laptops, and it's more than just your websites that you browse. It's in everything that you touch. So one of the things that you can think about is how does software help you achieve your goals, right? In your organization or in your business, does it help you meet your mission statement? Does it help you drive revenue or market share or shareholder value for your organization? Does it help you improve customer satisfaction? Are you delivering software updates to make your customers happier? Or do you have to deliver software updates for compliance reasons and legal reasons? Or is it just about being more efficient and productive to drive profits for your organization? So whatever your goals in your organization are, and I guarantee that you're going to have some of these goals in your organization, delivering better software faster can help you achieve those goals. So how do you do that? How do you deliver better software faster? How do you take code that's written in the development organization and have it running in a live production environment um, in production. Well, there's something that a lot of people are talking about called DevOps, and DevOps has, I think a great promise. DevOps, as defined by Wikipedia, is a software development method that stresses communication and collaboration and integration between software developers and information technology professionals. DevOps is really, involves technology and involves people, but it's really a cultural thing, right? DevOps transformation really results in a cultural outcome or a cultural change, which allows the development team and the operations team to work very closely together in order to drive better and faster software delivery, right? So it's kind of a cultural, outcome. It's a transformation that you want to achieve to move to DevOps. So that's why I say you can't really just do DevOps, right? You can't just buy a software product and install it and have DevOps. You can't just follow a recipe and end up, with DevOps, right? DevOps is a cultural outcome. It's going to require buy-in from a lot of different stakeholders across your organization, from all your teams, and it is going to require implementation of technology and probably change of processes and procedures. But it's really more of the goal. It's the outcome that you want to achieve. So if there's not any way that you can just do that by a cookbook, what can you do? Well, you can do continuous delivery. Continuous delivery is the application of a couple of things: automation and orchestration technologies, and some principles from the lean manufacturing world, applying these things to the software delivery lifecycle. So you're applying technology in terms of automation, and you're applying principles and methodology in terms of lean manufacturing, lean production ideas, applying those to the factory, the software factory that you have, right? The application delivery lifecycle, which is essentially, you can think of it like a factory for software. So CD then, continuous delivery, really can become the foundation for your DevOps transformation, right? So if you can implement a continuous delivery capability, then that takes you a long way to having the processes and the technologies you need to then be able to bring your teams together for the full cultural transformation for DevOps. So next question is, how do you do continuous delivery, right? What does that mean? What does continuous delivery really mean in terms of the way that you build and write and build software? Well, automation is the key word here, right? I mentioned it a couple times already. If we go back to the Tesla Motor Company example, they are, again, a very modern company, and they've leveraged automation in their factory floor to automate the entire process, right? So they have all these large factory robots that are actually putting the cars together. So automation is key for them, just as automation is key to the process of continuous delivery. Continuous delivery applies automation not to building cars, of course, but to the application lifecycle. So it applies automation to the process of taking code written in development and then getting it to production. And to do that, it has to go through a number of different stages, typically, right? The code is committed into a source code repository. The code is compiled and built, and libraries or dependencies are loaded. The code is then tested and then maybe deployed to a staging environment, and then finally deployed to production. And all the while, when you're doing this, you need to understand what's happening at each stage and provide feedback to the appropriate parties, to the developers or the operations team. So you need a powerful feedback loop for following this whole process. So CD, or continuous delivery, starts with continuous integration, or CI. Okay, CI has been around for a while. People are using it quite effectively, and it's all about automating the first step of the application lifecycle, right? Automating the build and test component. So what happens in CI is we have our developer on the left here, and he checks in some code into the source code control system. The CI server, or the automation engine, will be monitoring that source code control system, and it will see the check-in. It will then pull the code down, and it will run perhaps static code scans on it. It'll run the compile and build process, loading any dependencies, and then it can run tests on it, a variety of tests, unit tests or functional tests. So this CI server is essentially an automation engine that automates this whole process, right? Along the way, it's also providing a results report back to the developer. So he's getting the feedback on how the scan went, how the build went, and how the test went. And he can know whether the build was successful before moving forward. So again, using automation, automating the things that are often tedious and things that you don't want to do. One of my colleagues describes the CI server as for a 4-person development team, it's the 5th person who's sitting under the desk doing the work that the other 4 don't want to do, right? So running code scans, doing builds, running tests, that kind of stuff, but all in an automated fashion. Automation allows it to happen faster and also allows it to happen more accurately because there's less human error. So we've got CD in place now, or CI in place. Now CD then extends that automation across the lifecycle. So we go into the next 2 stages of the application lifecycle, deploying to a staging environment and running tests there, and then also deploying to the production environment. So continuous delivery really automates the full application lifecycle so that you can go from code commit to code deploy, fully automated, but also following all the steps that you normally follow in terms of testing, scanning, and verifying. So what you need for CD is an enterprise-grade automation platform now. This is going to become a mission-critical component of your application development process, your application lifecycle, and you need a mission-critical enterprise-grade platform to run it, right? You can't have the automation server that's running your continuous delivery capability, ever fall down or degrade. You also need to be able to manage complex, what they call pipelines. We'll talk more about this in a minute, but continuous delivery really defines pipelines that the code goes through from commit to deploy. And a pipeline can can be quite complex in some cases. It can have branches and restarts and forks, etc. So you need to be able to manage and understand complex delivery pipelines. And the final thing is you need to be able to deliver often not just the application from dev to production, but the environment configuration around the application. So the definition of the operating system environment, the environment variables, anything that that defines where the application runs, and be able to deploy that and carry that environmental information through the lifecycle along with the application. So delivering application and config. Sometimes people talk about this as configuration as code, right? Defining your configuration, storing it in a source code control system, and packaging it up with the application through the process. So that's an important notion. We'll come back to that in a little while. So both CI and CD actually extend the agile software development methodology. Agile has been around for a while. It's based on the idea of breaking application development up into small amounts. So small feature changes, small code changes, code written by small teams, and teams working in short cycles, like 2 or 3 week sprints. So the agile software development does that for the development side. CI and CD allow you to extend that by taking these small incremental software changes and making them available for delivery in a continuous fashion. So as soon as the Agile team finishes a sprint, that code should automatically go through the lifecycle, and it should be ready for deployment at any stage. What this gets you is fast feature delivery for your applications. So you can respond very quickly to market changes, to user requirements, to business changes, business drivers, whatever it is, you can develop and deploy new features much more quickly by taking this small iterative approach. Excuse me. You can also lower the risk of failure. So when you make small changes and push them through, the chance of that small change having a big impact is much less than if you're making a full major software release and trying to deploy that to production. And you can lower the error rate in production. When you're doing all this testing in an automated fashion along the way, you're catching errors much sooner. And when you do it with automation and with technology, you're even catching errors at a higher rate than you would with human interaction. So you're lowering the actual number of errors that may ever get to production. And fundamentally, you have happier customers, whether those customers are the end users of your organization, the business users, or your actual real customers out in the real world. You're going to be able to have happier customers, which means driving more revenue, driving more success for your organization. So CD involves, I touched on this earlier, involves creating pipelines for the application code. So you can think of a pipeline as the definition of the stages that the code will go through once it's committed. And you may have a bunch of pipelines actually running at the same time, because you may have multiple developers checking in code. You may have a single developer checking in code multiple times today. And each code check-in needs to go through the continuous delivery pipeline. So from commit to build to test to stage to deploy. And so the definition, by definition, CD involves creating these pipelines. And as I mentioned earlier, the pipelines can be quite complex. They can have decision trees and branches and forks, and they may need to be restarted. So the CD platform needs to be able to execute these pipelines, needs to be able to monitor them, and provide the feedback on where things are and how they're running. So this pipeline in this architecture example, if you will, is showing 4 different pipelines and different stages of success that those pipelines made it through. So this is just a representative example, a screenshot of a real product that runs a pipeline, happens to be Jenkins workflow, shows you a very similar view, right? You've had different dates, different check-ins, different times where the developers have checked in code, the builds that have happened. This bottom one failed, the second one was successful. In fact, made it all the way to staging. Anyway, you can see very visually and very graphically the results of the continuous delivery process, and for each check-in, giving you a sense of how things are running and where you are in your production environment. So what are some strategies for continuous delivery? What are some ways to think about implementing continuous delivery and different approaches that the customers we've seen take? Well, it comes in sort of a continuum. There's, obviously, it's like any capability maturity model. You have to start somewhere, and you want to get to probably the ultimate goal. So as we said before, continuous delivery is all about enabling organizations to roll out frequent updates of applications to address, whether it's business needs or business goals, and in doing so, minimizing, any risk of disruption. So where are you on this application delivery, spectrum? Well, let's look at each of these: manual delivery, basic automated delivery, blue-green delivery, and dynamic delivery, and see what people are doing. Delivery strategies in terms of manual delivery. So here is an example where the operations guy may say, my developers are pushing things live from their own boxes, and basically I'm terrified all the time, right? So this uses a manual approach. Involves packaging up the application. Perhaps you're using a CI process to do this, or perhaps it's just manual builds, and then rolling up a bunch of changes into a large kind of roll-up, right? And then you do that because this approach involves taking a maintenance window for your application in order to perform the upgrade. So that maintenance window may be, midnight on a Friday or Saturday night. Excuse me. And it may last from 30 minutes to multiple hours, right? How often have you gone to a website of a vendor and seen the sign that says, "We're working on things. We'll be right back." Basically, that's a maintenance window, and the staff uses that, and they push the application update to their servers directly from their own servers, from their own machines. So there's some risk in this approach, right? First is timely delivery. If you have to wait for these maintenance windows, are you able to get your enhancements out at the pace that you want to? And then integrity. How do you know what got pushed out and where it came from? When you roll up all this stuff into a big bundle, it's harder to track what changes came in and who they came from. And then how do you reproduce this version if you need to later, right? The working version that you had before. And then a reliability issue. Humans are involved, and so mistakes are going to happen at some point. So this is kind of a risky approach, but it's probably the state of the world for a number of organizations today, as they just begin to get their head around continuous delivery in DevOps. If we take a step up and look at basic automated delivery, this is a scenario where they've automated their deployments, but still struggling with downtime and rollbacks. So this approach means using a CI system to package up and do building and testing of the packages. Use a maintenance window still to turn the app off, but instead of having humans do the production upgrade, you're using automation scripts to update the primary application in the environment. The automation scripts such as Chef or Puppet or Ansible, allow you to speed up the process of delivering the updates and also make it more reliable because you're doing it with code rather than with human error. So it is faster and it can be more reliable, but there's still some concerns, right? The history concern, how do you track where the change came from? The verification concern, how do you know that the whole thing is working correctly once you've done it? And then the disruption concern, which is a big one, right? How long are the apps going to be down in this maintenance window? And how can you avoid that? And then how do you revert back to a known working version? So this is a little bit better, but still not great, right? The next strategy is blue-green delivery of applications. And this is a pretty interesting approach. It involves, automating the process and also being able to verify deployments across two different environments. So the approach involves having two completely separate production application environments, a primary and a secondary. And what you do is you upgrade your secondary environment using automation technologies, and then you flip a switch and promote the secondary to primary and the old primary back to secondary. So this allows you to have a very seamless update process for the users. There's no maintenance window required, and it allows you to have very simple rollbacks. If something's wrong with the new version, you just flip the switch back, and the old primary becomes the new primary. So there's definitely some advantages. We're seeing a lot of discussion about blue-green delivery in the industry. But there's still also some concerns about the history of tracking where changes came from and who made them, and the maintenance issue of running now what's essentially two production environments, the primary and the secondary, and keeping those up and running. So the final stage, dynamic delivery, is where your delivery is automated end-to-end, includes setting up new environments in a configuration and code type of approach, and having full verification when changes go live. So the approach here is to use continuous integration to produce the application packages, provision the new application environment as part of delivery. So I talked about this before, the notion of configuration as code, of being able to define the application environment, not just the application, and be able to deliver that environment, whether it's operating system versions or environment variables or whatever, with the application code itself. So this approach, dynamic delivery, involves that. When you deliver the new application, you're actually standing up the new environment with it as well. So you can run verification tests against that new environment, and then promote the new environment with the flip of the switch to become the old environment. So it's similar to blue-green, except that you're creating a new environment with automation technologies every time you deploy the application code. So it has seamless updates and verifications, it has rollbacks. They're very simple. Just switch back to the old environment, and it allows you to reliably reproduce the application environment because you're defining it in code. You're capturing that completed application environment in code. So this is really gets to kind of the almost the quote-unquote DevOps nirvana, right? You're able to very quickly deploy application and environment together. You still need to worry about where the code changes came from, and you need tools that can help you do that. And it also requires that you have this ability to spin up environments. And that's really kind of a cloud-like characteristic, right? You need automatic and self-service provisioning capability that either a cloud or an environment, or having tools like Puppet and Chef can help you, provision and deploy. So that's the kind of the ultimate way is to treat your environment configuration as code and deploy full environments with the application when needed to roll out a new release or a new update. So let's talk a little bit about continuous delivery with CloudBees Jenkins Enterprise, and we'll define what that is in a minute here. Jenkins is really the #1 automation platform used for CI. A number of different surveys have polled people, and 70% of the people that are doing continuous integration are using Jenkins for it. It's vastly popular. Almost every organization out there has Jenkins running somewhere within it. So it's a very powerful tool. It's been around for about 7 years now, and it does the automation tasks very well. It's also very flexible and has a lot of integration points for integrating other tools that it needs to perform some of the functions. For example, for running testing, Jenkins won't actually run the test itself, but Jenkins will call the testing tools and have them execute the test and get the results back. Same for doing the application builds. Jenkins will utilize Maven or whatever it needs to perform the application builds. So Jenkins really becomes the orchestrator or the hub of this process, and it has an automation engine that allows it to execute this CI process, right? Well, CloudBees is the enterprise company behind Jenkins. We have a number of engineers that work directly on Jenkins, and our CTO, Kosuke Kawaguchi, is the founder of Jenkins. So we have a lot of really smart Jenkins guys, and we've continued to work and improve Jenkins over the years. One thing we've added recently is Jenkins Workflow and the Workflow Stage View, which allow Jenkins to really become a full continuous delivery platform now. So Jenkins Workflow allows you to create very complex and robust CD pipelines and manage them all within Jenkins. So Jenkins really becomes now not just a CI tool, but really becomes your key to continuous delivery. So Jenkins can now manage the full CI process as well as the deployment to stage and deployment to production, and it can do it with very complex pipelines that have restart checkpoint capabilities, branching and forking, etc. And it can also integrate with the tools to deliver configuration as code as well. So CloudBees is the company behind Jenkins. We actually enable Jenkins at enterprise scale. So the CloudBees Jenkins Enterprise is the enterprise version of Jenkins. It comes with capabilities that allow you to stand up Jenkins and run it at scale in an enterprise fashion. So it allows Jenkins to become a mission critical piece of your environment by providing high availability capabilities, role-based access control, a number of other enhanced capabilities that enterprises need when you want to run the CD platform, which becomes now mission critical. So Jenkins has over 1,000 plugins for different integrations with different tools. So if you look at the lifecycle, there's a lot of tools that are involved by the development and the testing and the operations teams, right? Jenkins can integrate with almost all of these, whether they're IDEs and editors or source code control systems, API-based testing frameworks, release management, release automation software, automated API-based testing frameworks for static code analysis, load testing tools, user acceptance testing tools, and then release management and environment configuration and management software. So Jenkins has these plugins that allows Jenkins to directly integrate with all of these tools, making Jenkins really the most connected CD platform. So no matter what stage of the process you're trying to automate, Jenkins becomes the hub and the automation engine, and it calls out to the tools that it needs to, whether it's doing the source code control or the build tools, doing testing on the applications, doing staging and deployment, or even running the application. Jenkins can deploy directly to these cloud environments or to these on-premise application environments as well. So it has the plugins for the tools you need, whether you want to run your application on premise or in the cloud. So very powerful capability, and it's all the proven Jenkins software that's been running, probably in your shop for a long time. Very well respected and easy to use software platform that now allows you to deploy a full continuous delivery environment. So how can CloudBees Jenkins Enterprise help with the CD strategies we talked about before? Well, Jenkins Workflow is this extension of Jenkins that allows you to define flexible delivery pipelines. It has some capabilities like deployment history tracking. One of the key things that we talked about in almost every scenario is understanding who kicked off a deployment and where that code came from. Deployment verification, leveraging verification tests to determine the quality of a new deployment. Automated rollbacks, so defining the rollback strategy in case something fails. And it actually supports blue-green deployments, so you can leverage the workflow capability for zero downtime deployments, or even if you want to do the dynamic environment creation for full dynamic delivery. Spin up new environments using the tools that integrate with Jenkins to define the configuration as code and deploy those with your pipeline. CloudBees Jenkins Workflow Stage View, just a larger view of the screenshot we showed before, but it shows some of the capabilities within the workflow product, the workflow CD pipeline tool. Couple of quick examples: it has restartable checkpoints so that you can restart a pipeline at any stage along the way. So if a pipeline fails at some point, you don't have to go all the way back to the beginning. You can restart it from the point where it was last successful. You can also download the artifacts along the way to see where they were when they failed or when they were successful. So that's the workflow stage view. We talked about the restarting deployments. This is a very powerful capability for a CD pipeline tool. Allows you to define the pipelines in a way that allows you to restart them right after they fail, and so that saves you a lot of time. You don't have to go back and rerun the entire pipeline, which can be fairly expensive. Cluster operations. So CloudBees Jenkins Enterprise allows you to run Jenkins master servers in a cluster for high availability. So as we mentioned before, if you're doing continuous delivery, the continuous delivery platform is going to be a mission critical part of your environment now, right? Because your applications depend on it, your teams depend on it, and your customers depend on it. So to be able to run a fully highly available instance of Jenkins becomes critical, and the Jenkins Enterprise, CloudBees Jenkins Enterprise, allows you to do that with the HA capability. CloudBees Jenkins Enterprise also has the Jenkins Analytics dashboards for monitoring and analyzing the performance across all your Jenkins environment. You may have a number of different Jenkins servers, different master servers and slave servers, and you want to understand how things are running within those servers across different jobs, across different pipelines and different workflows. The analytics dashboards can help you do that. So just to kind of sum up and recap a little bit about what we talked about. We talked about the fact that delivering better software faster is really driving the agenda for almost every organization today, right? Software is eating the world, as Mark said. We also talked about how continuous delivery now allows you to do that, to deliver better software faster, because continuous delivery leverages the automation and the lean manufacturing principles to allow you to streamline the application delivery process, but do it with technology, with automation, with technology, so that you're taking the human out of the loop. And we talked about how continuous delivery really can be a step towards your DevOps transformation, right? Continuous delivery gives you the technology and the process you need in order to bring to your environment and to your teams the capabilities they need to be able to move to a DevOps culture, a DevOps transformation. Jenkins, as we've seen with all the integrations and the thousands of plugins, really is the hub for continuous delivery. It becomes the automation engine that powers the continuous delivery pipelines. And CloudBees Jenkins Enterprise brings you the enterprise scale for that. It brings you the high availability, role-based access control, a number of other capabilities that enterprises depend on when they're running Jenkins at massive scale. So I want to wrap up really quickly, and we'll turn it back over to Alan for some Q&A. But I did want to have a quick advertisement. If you want to learn more about continuous delivery, we've got a couple of exciting events coming up. We have a Continuous Delivery Summit World Tour, where we'll have experts and practitioners there, keynote speakers Gene Kemp and Kurt Bittner from Forrester. Gene Kim wrote the Phoenix Project. Should be some great sessions. We're going to have 3 of these events. Washington,